Welcome back! CSEC Chemistry, June 2023, Paper 2, Full Solutions for Questions 4 to 6. Let's start. Question number 4A. Sulfur and magnesium are two elements in the same period of the periodic table. The different properties of the oxides of these elements are presented in Table 2. Part 1. With reference to bonding, explain the difference in melting point between the oxides of sulfur and magnesium. This values 6 marks, therefore 3 marks for the explanation for the oxides of sulfur and 3 marks for the explanation for oxides of magnesium. The oxides of sulfur are covalent compounds with covalent bonds between oxygen and sulfur. Also, there are weak intermolecular forces of attraction between each molecule. These forces break easily with little amount of energy, hence the melting point is low. However, the oxide of magnesium is an ionic compound and has a giant ionic lattice. There are strong ionic bonds between the cations and anions. These strong electrostatic forces of attraction between ions requires a lot of energy to break the bonds. Therefore, the melting point is very high. Part 2. Explain whether the oxides of sulfur and magnesium will conduct electricity, and if so, under what conditions. The oxides of sulfur will not conduct electricity under any conditions because these compounds consist of nonmetals which are poor conductors of electricity. Also, there are no mobile electrons or ions in oxides of sulfur. In contrast, the oxide of magnesium will conduct electricity in the liquid or molten phase because this compound has mobile ions. These free and moving ions are able to transfer electrons, resulting in the conduction of electricity. B. Figure 4 is a partial diagram of the apparatus a group of students intend or propose to use to investigate whether ethanol, aqueous ammonia, and aqueous lead-2 nitrate would conduct electricity. Part 1. Complete the diagram in Figure 4 in order to make a circuit that is suitable for achieving the aim of the experiment. First, draw a container with the electrodes immersed in the liquid. Now we write liquid because this is an experiment and we are not sure which is the electrolyte. The first trial for the experiment, the liquid could be ethanol. The second trial, aqueous ammonia. And the third trial for the experiment, the liquid could be aqueous lead-2 nitrate. Also, you're going to need a lamp, so we draw a lamp above the cathode. The lamp will shine, producing light energy if the liquid conducts electricity. That will give you 2 marks. Part 2. Classify the 3 substances to be investigated: ethanol, aqueous ammonia, and aqueous lead-2 nitrate, either as conductors or non-conductors. Conductors will be aqueous ammonia and aqueous lead-2 nitrate. Aqueous ammonia and aqueous lead-2 nitrate are conductors because ammonia and lead-2 nitrate, when dissolved in water, have free mobile ions to conduct electricity. Whereas the non-conductor is ethanol. Ethanol would be a non-conductor because it does not ionize when dissolved in water. Therefore, it cannot conduct electricity. Question number 5. A. Anaerobic fermentation occurs when yeast is used in the production of wine. Part 1. Define the term anaerobic fermentation. Anaerobic fermentation is the conversion of carbohydrates into smaller molecules that occurs without oxygen. Stressing without oxygen, that's important to get the 2 marks. Part 2. State one reason why high temperatures are not suitable for anaerobic fermentation. High temperatures denature or kill the yeasts which act as catalysts during fermentation. Part 3. Write a balanced equation for the anaerobic fermentation of glucose. The chemical formula for glucose is C6H12O6 aqueous, and this will be converted in the presence of yeast at 37 degrees Celsius to ethanol C2H5OH aqueous plus carbon dioxide CO2 gaseous state. This equation is not balanced since there are 6 carbons on the reactant side and 3 carbons on the product side. There are 12 hydrogens on the reactant side while 6 hydrogens on the product side. Also, there are 6 oxygens on the reactant side while 3 oxygens on the product side. In order to balance this equation, we are going to write the coefficient or the numeral 2 in front of ethanol on the product side. Also, write the numeral 2 in front of the carbon dioxide. This is a balanced equation. B. Soaps are formed from the alkaline hydrolysis, which is saponification, of natural oils and fats, esters. Compound E, shown below, is an ester which is hydrolyzed by aqueous sodium hydroxide. Draw the fully displayed structures of the hydrolysis products. The hydrolysis of compound E in aqueous sodium hydroxide will break the single bond between carbon and oxygen in the ester functional group. This will result in a carboxylate salt known as sodium acetate having 2 carbons, where 1 carbon is bonded to 3 hydrogens and another carbon with a double bond O. There is a single bond between this carbon with oxygen, and the oxygen is bonded to sodium. I placed the oxygen and the sodium in different color because this portion of the molecule comes from the aqueous sodium hydroxide. The other compound formed is ethanol, having 2 carbons, 5 hydrogens, and a hydroxyl group. Since you were asked to draw fully displayed structures, you must show all the bonds in both molecules as individual lines in order to get full marks. See Part 1. Name the byproduct of the saponification of fats and oils. The answer is glycerol. Part 2. State one difference between the effect of using soaps and soapless detergents on hard water. Soaps do not lather, meaning foam of bubbles, in hard water, but soapless detergents lather in hard water. D. Figure 5 shows the structures of an amino acid and propene. Part 1. State the type of polymerization that the amino acid in Figure 5 would undergo. The answer is condensation polymerization. Part 2. State the general name for the type of polymer formed from the amino acid in Figure 5. The answer is polyamide. Part 3. State 2 chemical tests that can be used to distinguish between propene and its polymer. Propene is an alkene containing a double bond between carbons, while its polymer would be an alkane containing only single bonds. Hence, test 1 to distinguish between alkene and alkane is bromine water test. Bromine water has an orange color. When propene mixes with bromine water, there is a color change from orange to colorless. But there is no color change when the polymer mixes with bromine water. So the mixture remains orange in color. Another test is test with Bayer's reagent, which is cold potassium permanganate solution. This solution has a purple color. When propene mixes with this reagent, propene changes the purple solution to colorless, but there is no color change when the polymer mixes with Bayer's reagent. So the mixture remains purple. Question 6. A. Farmer Brown reaped a crop of vegetables and reported that the yield was far below what was expected. An analysis of the soil revealed that there was a deficiency of magnesium. Part 1. Outline the importance of magnesium on plant health. Magnesium is important in plants because it helps with the formation of chlorophyll, the green pigment found in plant leaves. Chlorophyll absorbs energy from the sunlight, allowing plants to make their own food by photosynthesis. Also, magnesium aids in the activation of plant enzymes needed for growth. Part 2. Explain how a magnesium deficiency can result in the low yield of vegetables. A magnesium deficiency causes chlorosis, which is the yellowing of plant leaves. This deficiency decreases the amount of chlorophyll in the leaves, which in turn lowers the amount of energy captured from the sunlight for the plant to photosynthesize. When this happens, plants will make less food until photosynthesis stops. As a result, the deficiency will lead to poor and stunted plant growth. There will be a low yield of vegetables and eventually death of plants. Part 3. State 2 other metal ions which are important to plant growth and the results of each deficiency. The first metal, manganese. The deficiency is dark green bands on the main veins of leaves, since manganese activates enzymes and assists to make chlorophyll. Another metal is boron. The deficiency is older leaves turning yellow and may result in badly formed fruit, since boron aids in the formation of cell wall, pollen grain, and seed. Another metal is cobalt. The deficiency is older leaves turning yellow, since cobalt is needed for the fixation of nitrogen in legumes. Also, copper. The deficiency is leaf tips turning yellow and leaves drooping, since copper activates enzymes, helps in photosynthesis and plant reproduction. B. The Caribbean Sea and many oceans around the world have been found to be polluted by solid waste, mainly in the form of plastics. Part 1. State 2 examples of plastic waste that are commonly found in the seas and oceans. Examples could be plastic bottles, plastic bags, plastic bottle covers, plastic straws, plastic cups, and plastic ropes. Any two or other two plastic solid wastes. Part 2. Discuss 2 harmful effects of plastics on marine life. Marine species swimming in the sea can get caught in plastic debris. This will entangle and trap animals like a turtle, and the animals will not be able to move properly. As the animals try to escape, they may get injured, leading to death. Another harmful effect: marine animals may see a plastic item like a bottle cover and ingest the plastic debris. This will result in suffocation and eventually death. This is the end of question 6. Thanks for watching and all the best.